Their scanners picked up a large circular structure that looked as if it was constructed, designed, shaped, and it had odd marking.
In 2011, a Swedish treasure hunting crew was not looking for aliens. They were looking for shipwrecks, champagne, and anything valuable enough to pull from the dark floor of the Baltic Sea. Then their sonar caught a shape that looked impossible. A huge circular formation sitting 300 feet below the surface, with sharp edges, strange lines, and what looked like a long scar behind it. For years, people called it a crashed UFO, a lost military base, even proof of an ancient civilization. But the real answer may be even stranger, because the proof shows this was not built by aliens. It was built by ice, the dive that turned rumor into evidence. Diving to 300 feet in the Baltic Sea is not like diving in warm, clear water for a travel documentary. It is dangerous, technical, cold, dark, and slow. At that depth, the pressure is serious. The margin for error is small. The dive must be planned carefully, and coming back up is not as simple as swimming to the surface. Divers need decompression stops to avoid the bends, and every minute at depth increases the difficulty of the return. Then there is the Baltic itself. Visibility can be terrible. Fine sediment hangs in the water. A flashlight beam does not cut cleanly through the darkness. It spreads into a fog of reflected particles. Shapes become partial. Distance becomes hard to judge. A ledge can look like a wall. A crack can look like a hallway. A circular stain can look like a hatch. When you already know you are diving toward one of the strangest sonar targets ever found, the brain is ready to turn every feature into a clue. That is what makes the diver reports so important and so tricky. The divers said they reached a hard, massive structure on the seafloor. They described smooth, dark stone, strange angles, and features that felt unnatural. Some descriptions made it sound almost like exploring the remains of a bunker or a machine. But human perception underwater, especially under stress, is not the same as controlled laboratory observation. The environment itself is part of the illusion. Still, the dive mattered because the team did something that speculation could not do. They collected samples. That changed the story. Before that, the mystery was built on sonar images, eyewitness descriptions, and imagination. After the dive, there were physical fragments that could be tested. That is where most internet mysteries fall apart. A blurry shape can become anything online. A sample cannot. If the Baltic Sea Anomaly were a crashed spacecraft, the material should show something unusual. If it were a military installation, there might be metal, engineered alloys, ceramics, concrete, synthetic materials, or signs of human manufacturing. If it were an ancient structure, the rock might show tool marks, carving, mortar, shaped blocks, or patterns of construction. But if it were natural, the samples would show natural minerals. Granite, gneiss, sandstone, basalt-like rock, the kinds of materials geologists expect from a region shaped by ancient bedrock, glacial movement, and seafloor processes. That is exactly why the samples became the turning point. They did not give people the answer they wanted. They gave them the answer the rocks supported. This is the part of the story where the mystery becomes better, not worse, because the proof did not say the anomaly was fake. It said the anomaly was real, but misunderstood. There was something down there. The sonar did detect a real feature. Divers did touch hard material. The samples were real. The mistake was not believing in the object. The mistake was assuming that if nature made something strange, it must not be nature at all. The proof inside the rocks. When geologists examined the samples, the exotic theories lost their strongest ground. The fragments were not made of unknown metals. They were not advanced composites. They were not artificial ceramics or aerospace materials. They were ordinary earth rocks, including granites, gneisses, sandstones, and a basalt-like volcanic rock. At first, that sounds like a letdown. After years of UFO theories and dramatic speculation, the answer being rock can feel almost insulting, but that reaction misses the point. In geology, rocks are not boring. Rocks are records. They carry the history of pressure, heat, movement, erosion, and time. The question is not just what the samples were made of. The question is how those rocks ended up there, in that shape, at that location. That is where the Ice Age enters the story. Northern Europe was once buried under massive ice sheets. During the last glacial period, the Scandinavian ice sheet covered enormous parts of the region. This was not a gentle blanket of snow. It was a moving machine. In places, the ice was thousands of feet thick, its weight pressed down on the land with unimaginable force. As it moved, it scraped bedrock, tore loose boulders, ground stone into sediment, and carried rocks far from where they originally formed. A glacier can pick up a rock from one place and drop it hundreds of miles away. When that happens, the rock is called a glacial erratic. Erratics are often confusing because they look out of place. A boulder made of one kind of rock may be found sitting in a landscape where that rock does not naturally belong. Before modern geology, people had all kinds of strange explanations for them. Now we know the real answer: ice carried them. That is why the basalt-like rock at the Baltic Sea Anomaly does not require an underwater volcano or a crashed machine. Basalt is volcanic, but glaciers can transport volcanic rock. The Baltic Basin was shaped by glacial processes. Rocks from different geological regions can end up mixed together because ice does not care about our modern maps. It drags, crushes, drops, and leaves behind puzzles for future humans to misunderstand. The same applies to the shape. People saw sharp edges and imagined engineering, but natural rocks can fracture along planes that look surprisingly straight. Under pressure, stress, freezing, thawing, and erosion, rock can split into blocks, ledges, steps, and angular surfaces. In bad sonar data or poor underwater visibility, those shapes can look designed. Then there were the so-called scorch marks. Divers and viewers described dark surfaces that looked burnt or heat damaged, but underwater rocks often develop dark coatings from minerals and biological growth. Manganese and iron oxides can make stone look metallic or blackened. Bacteria and algae can create coatings that look strange under artificial light. A diver's flashlight in murky water can make a natural surface look like a charred wall. And the long trail behind the anomaly? That may be one of the easiest features to misunderstand. If a large, hard object sits on a softer seabed, currents moving around it can accelerate and carve sediment away. Over time, that creates a scour mark or shadow behind the object. It can look like a crash path, but it does not require impact. The rock did not need to slide into place like a fallen spaceship. It could have been dropped by melting ice, then shaped by thousands of years of water moving around it. That is the solution. A real object made of real rock, likely shaped and placed by glacial action, then modified by seafloor currents and biological coatings. The shape that made the Baltic go silent. The Baltic Sea is already a perfect place for a mystery. It is cold, murky, and loaded with history. For centuries, ships crossed those waters carrying timber, iron, grain, weapons, alcohol, luxury goods, and military cargo. Many of them never made it home. Some sank during storms. Some were lost during wars. Some simply vanished into the dark and were forgotten until modern sonar began mapping what human memory had lost. That is why treasure hunters go there. The Baltic can preserve wrecks unusually well because of its cold, low salinity water. Wooden ships can survive there for centuries. Bottles of old champagne and cognac have been recovered from shipwrecks and sold for enormous prices. So when the Ocean X team went scanning the seafloor in 2011, they were not expecting a scientific revolution. They were expecting the usual pattern of wreck hunting: long hours, repetitive sonar lines, and maybe one good hit if they were lucky. Side-scan sonar works by sending sound waves across the seafloor and measuring the echoes that bounce back. It does not give you a clean photograph. It gives you an interpretation of shape, texture, shadow, and distance. That matters because sonar can make natural features look stranger than they really are, especially when the seafloor is uneven or the object has strong edges. But when the Ocean X crew saw the return, they knew it was not a normal wreck signature. A shipwreck usually has a certain chaos to it: broken ribs, collapsed hull sections, debris fields, scattered metal, and irregular shadows. This object looked too clean, too circular, too separate from the surrounding seabed. And behind it, the long mark across the bottom made the whole thing feel even more unnatural. It was easy to imagine something huge landing, sliding, or carving its way into the mud. The crew scanned it again. That is the part that gave the story weight. If it had only appeared once, it could have been dismissed as a glitch, a false echo, or a distortion in the water. But when they ran another pass, the same shape appeared again. It was really there. Once the sonar image reached the public, the story became impossible to control. People called it the Baltic Sea Anomaly because nobody had a better name. The media leaned into the mystery. Forums studied the images. Documentaries speculated. Every strange detail became evidence for somebody's theory. The circular shape became a disc. The marks became corridors. The trail became a crash path. The dark coating became burn damage. And the reported equipment failures became the most dramatic part of all. According to the crew, when they returned to the site, some electronics acted strangely near the anomaly. They described communication problems and equipment issues that seemed to happen only when they were close to the object. That claim was never proven in a way that could settle the case. But as storytelling, it was explosive. A strange object is one thing. A strange object that allegedly interferes with electronics is something else entirely. That is how mysteries grow. First comes the object, then the atmosphere, then the detail that feels impossible to ignore. The Baltic Sea Anomaly had all three. It had a location people could not easily visit. It had a shape people could not easily explain. And it had just enough technical weirdness to make ordinary answers feel too small. But sonar does not solve mysteries by itself. It creates questions. To answer them, someone had to go down. The Ice Age Builder. The original twist for this version is simple. The Baltic Sea Anomaly was not proof of alien engineering. It was proof that the Earth can engineer illusions better than humans can invent them. That is what makes the story powerful. The anomaly looked like a machine because people were seeing the final result of several natural systems stacked together. First, the Ice Age moved the material. Then, geological fractures shaped the rock. Then the Baltic Sea formed around it. Then deep currents scoured the sediment behind it. Then dark mineral and biological coatings changed its surface. Then side-scan sonar flattened and stylized the image. Then human imagination did the rest. Each step added another layer of mystery. The glacier put the rock somewhere it seemed not to belong. Fractures gave it straight lines. Currents gave it a trail. Coatings made it look scorched. Sonar made it look geometric. The internet made it look impossible. That is a much better story than a simple hoax because no one had to fake the object. The anomaly was strange enough on its own. The mistake was interpreting a natural process as artificial design. Think about how powerful a glacier really is. It can carve valleys, polish bedrock, move house-sized boulders, grind mountains down, and reshape entire regions. It does all of this slowly, but slowness is not weakness. In geology, time is the amplifier. A weak force acting for long enough can do what no explosion can. A river can carve a canyon. A glacier can move a mountain. A current can sculpt a seafloor. That is why the anomaly belongs to deep time. It is not a message from another civilization. It is a leftover from a world that existed before cities, before writing, before the Baltic Sea looked the way it does today. It is a tombstone from the Pleistocene, the epoch when ice ruled northern Europe and shaped the ground beneath modern nations. The best part is that this explanation does not make the anomaly smaller. It makes it larger. A UFO theory explains one object. The Ice Age explanation explains an entire landscape. It connects the object to Scandinavia's bedrock, the movement of ancient ice sheets, the formation of the Baltic Basin, the behavior of underwater currents, and the way humans misread patterns when they want a mystery. The Baltic Sea Anomaly was not a machine. It was a trap for the human brain. It looked just artificial enough for imagination to outrun evidence. Why the mystery still matters. So why does the Baltic Sea Anomaly still matter if the strongest evidence points to geology? because this story teaches us how modern mysteries are born. It begins with a real observation. The Ocean X team really did find a strange sonar target. The image really did look unusual. The site really did attract attention. Divers really did retrieve samples. The samples really did contain natural rocks. The mystery was not invented from nothing, but between observation and explanation, something happened. The public filled the gap. That is where most legends live, in the space between what we can see and what we can prove. A blurry image becomes a structure becomes a craft. A reported equipment problem becomes an energy field. A current scour mark becomes a crash trail. And once a story becomes exciting enough, every ordinary explanation feels like an insult. That is why solving the anomaly does not completely kill the debate. Some people will always prefer the stranger theory because it feels bigger, but the scientific explanation has something the others do not: physical evidence and a known mechanism. Glaciers can move rocks. Rocks can fracture naturally. Currents can scour sediment. Mineral coatings can darken surfaces. Sonar can distort perception. Every piece of the natural explanation is something we already know happens in the real world. The UFO explanation has a different problem. It must explain everything by adding new assumptions. A craft no one has identified. A crash no one can date. Materials that samples did not show. Technology that left no clear technological trace. A structure with no confirmed engineering. That does not make it impossible in a fantasy sense, but it makes it weaker as an explanation. The strongest answer is usually the one that explains the most with the fewest unsupported claims. In this case, geology wins. But that does not mean the Baltic Sea anomaly was worthless. In fact, its value may be the opposite. It pushed people to look closer at a part of the world most of us never think about: the sea floor. It reminded the public that the Baltic is not just an empty body of water between countries, but a layered archive of shipwrecks, ancient geology, war history, glacial debris, and natural formations that can still surprise us. It also showed how powerful sonar imagery can be in shaping a story. One strange scan, viewed without full context, was enough to spark more than a decade of theories. That says something about technology, but it also says something about us. We trust images, even when they are not really images. Sonar does not show the seafloor the way a camera does. It gives us shadows, shapes, and echoes, and the human brain fills in the rest. Most importantly, the anomaly revealed how little many people understand about the Ice Age forces that built the world under our feet. Glaciers did not just melt and disappear. They carried rocks, carved basins, scraped landscapes, and left behind objects so strange that thousands of years later they could still be mistaken for machines. In that sense, the Baltic Sea anomaly was not a failed mystery. It was a reminder that Earth's own history is powerful enough to look impossible. The real lesson is not never believe mysteries. The real lesson is follow the evidence until the mystery changes shape. At first, the mystery was, is there a crashed craft under the Baltic Sea? After the samples, the better mystery became, how did natural forces create something that looked so artificial? That second question is more useful because it teaches us something real. It teaches us about glaciers, seabed currents, mineral coatings, sonar interpretation, and human psychology. That is the story worth telling. In the end, the Baltic Sea anomaly was not solved by a secret file, a government confession, or a hidden alien signal. It was solved by stone. The sonar image made the object look impossible. The reported equipment failures made it feel dangerous. The divers made it real. But the samples told the truth. Granite, gneiss, sandstone, basalt-like rock, natural fractures, dark coatings, glacial movement, and current scouring. So what do you think? Is the glacial explanation finally enough to close the case? Or do you still believe something stranger is hiding under the Baltic Sea? Drop your thoughts in the comments. And if you want more stories about strange discoveries, lost objects, and mysteries that turned out to be even deeper than the rumors, make sure to like this video, subscribe to the channel, and turn on notifications so you do not miss what comes next.